Imagine a force so powerful that it can halt the birth of stars and bring an entire galaxy to a standstill. This isn't science fiction, it's the reality of the universe we live in. And today, we're going to explore one such force, a supermassive black hole-powered quasar, a discovery that's showing us the universe as it was nearly 13 billion years ago. Quasars are some of the most mysterious and energetic objects in the cosmos. They're powered by gigantic black holes at the center of galaxies. These black holes, as they feed on surrounding gas and dust, produce immense amounts of light and radiation, enough to outshine an entire galaxy of stars. Think about that for a second, a single object brighter than a trillion stars. It's mind-blowing. One of the most fascinating quasars ever discovered is known as J1007+2115. Using the James Webb Space Telescope, scientists have found this quasar 13.1 billion light-years away. That means we're looking at it as it was only 700 million years after the Big Bang. To put it another way, we're seeing a piece of history from when the universe was only about 5% of its current age. But what makes J1007+2115 truly special isn't just how old or distant it is. This quasar is generating a massive wind that's sweeping across its galaxy, a wind so powerful that it's pushing away the very gas and dust needed to form stars. In other words, this quasar is killing its own galaxy. And it's unlike anything we've ever seen from such an early period in the universe. This discovery doesn't just tell us about one quasar, it tells us something fundamental about how galaxies form and die. Quasars like J1007+2115 could have played a huge role in shaping the early universe. And as we continue to explore, we'll learn even more about the forces that have shaped our own galaxy, and maybe even the future of the universe. Quasar J1007+2115 was discovered using the powerful James Webb Space Telescope, one of the most advanced tools ever built to explore the cosmos. The James Webb has a unique ability to look back in time, allowing astronomers to observe the universe as it was billions of years ago, during the birth of the first galaxies and some of the earliest events that shaped the cosmos. J1007+2115 is one of the most remarkable discoveries made so far. Located 13.1 billion light-years away, it shows us a galaxy as it was just 700 million years after the Big Bang. This means we are witnessing a snapshot of the universe when it was incredibly young, a time when the first galaxies were just beginning to take shape. What makes J1007+2115 stand out is the sheer power of the winds generated by the supermassive black hole at its center. These galactic winds stretch across 7,500 light-years, a distance equivalent to about 25 solar systems lined up in a row. The material carried away by these winds every year has the mass of 300 suns, and all of it is being expelled at a staggering speed of 4.7 million miles per hour, which is about 6,000 times the speed of sound. These winds are not just incredibly fast and powerful, they are literally changing the fate of the galaxy. By blowing away gas and dust, these winds are preventing new stars from forming. This galaxy, which is rich in material that could give birth to stars, is being suffocated by its own quasar-driven winds. The discovery of this quasar isn't just a cosmic curiosity, it's a critical clue in understanding how the earliest galaxies evolved. So far, J1007+2115 is the oldest quasar with such powerful winds ever observed, leading scientists to believe that phenomena like this may have played a crucial role in shaping the first structures of the universe. At the heart of quasar J1007+2115 is a supermassive black hole, millions to billions of times the mass of our Sun. As it consumes surrounding gas and dust, the energy it releases creates not only immense light but also powerful winds that blow outward across its galaxy. These winds, however, aren't just a spectacle, they are agents of cosmic destruction, capable of shutting down star formation and altering the destiny of entire galaxies. Let's dive into how this process works. In a typical galaxy, star formation happens when gas and dust, primarily hydrogen, collapse under gravity and ignite to form new stars. This is the life force of a galaxy. The more gas and dust available, the more stars can form, and the brighter and more active the galaxy becomes. In its early stages, the galaxy around J1007 plus 2115 was likely a vibrant, star-forming environment, rich in molecular clouds that serve as the building blocks for new stars. However, the winds from the supermassive black hole changed all of that. These winds, moving at 4.7 million miles per hour, act like a cosmic broom, sweeping out the material needed for star formation. Imagine a city where all the resources, water, food, energy, are suddenly pushed away. No new growth can happen. That's exactly what's happening in this galaxy. The winds are stripping away the gas and dust, the very elements necessary for new stars to be born. This is what astronomers call quenching star formation. What's even more astonishing is the scale of these winds. They stretch out for 7,500 light-years, affecting a huge portion of the galaxy. To put that into perspective, our entire solar system would be just a tiny speck in comparison. The winds from J1007 plus 2115 are like a force of nature, reshaping everything in their path, leaving behind a barren landscape where no new stars can form. This process effectively kills the galaxy by shutting down its ability to create new stars. Without new stars, the galaxy grows old and dark. Over time, the existing stars burn out or die, and with no new stars to replace them, the galaxy becomes a dead system, a galaxy without the ability to renew itself, forever frozen in time. This is what astronomers call a dead galaxy. But here's where it gets really interesting. The winds don't just stop star formation. They also cut off the supply of gas and dust that the black hole itself needs to grow. Just as the black hole's energy is stopping stars from forming, it's also starving itself of the material it needs to feed on. This creates a feedback loop. The more powerful the winds become, the more they inhibit both star formation and the growth of the black hole. This might explain why some galaxies, including our own Milky Way, have supermassive black holes at their center that are no longer actively feeding or growing. Now, this raises an intriguing question. How many other galaxies in the early universe met the same fate? How many star-forming galaxies were snuffed out by the winds of their own central black holes, turning them into barren, starless relics? J1007 plus 2115 is a glimpse into a much larger phenomenon, one that may have shaped the evolution of the entire universe. As astronomers continue to study J1007 plus 2115, they hope to find more examples of these powerful quasar winds in other early galaxies. By understanding how these winds operate, scientists can unlock the secrets of how galaxies lived, grew, and died in the early universe. Quasar winds might be one of the most influential and destructive forces in the cosmos, playing a pivotal role in the story of how our universe evolved from a chaotic, star-forming nursery to the vast, complex structure we see today. In summary, J1007 plus 2115 is not just a distant quasar. It's a window into the processes that shaped entire galaxies, and perhaps even the future of our own galaxy. With every new discovery, we are learning that the universe is far more interconnected than we ever imagined, where the death of stars and the growth of black holes are two sides of the same cosmic coin. As we peer deeper into the cosmos, it becomes clear that quasars like J1007 plus 2115 aren't just isolated phenomena, they are key players in the evolution of galaxies. To understand how galaxies grow and change over billions of years, we need to consider the powerful influence of supermassive black holes and the intense energy they unleash. These forces may have shaped the galaxies we see today, including our own Milky Way. In the early universe, galaxies were chaotic, bustling hubs of activity. Stars were forming at an incredible rate as clouds of gas and dust collided and collapsed under the force of gravity. But this frantic pace of star birth couldn't last forever. At some point, galaxies had to settle down, and quasars might have been the agents that forced this change. When a galaxy hosts a quasar, the supermassive black hole at its center begins feeding on vast amounts of gas and dust, generating tremendous energy. As this energy radiates out, it doesn't just create light, it also triggers the galactic winds that push away the material that fuels star formation. This is where the quasar's role becomes crucial in the evolution of its host galaxy. By expelling this star-forming material, the quasar effectively shuts down the galaxy's ability to create new stars, leading it toward a quieter, less active phase. Over time, the galaxy transitions from a vibrant, star-forming system to one where star birth slows down dramatically or even stops altogether. The galaxy begins to age. The bright, young, massive stars burn out, and without new stars to replace them, the galaxy starts to fade. This is what astronomers refer to as a quenched galaxy, a system where star formation has come to a halt. And in many cases, quasars are the trigger for this process. Now, this raises an interesting question. If quasars are so destructive, how did galaxies like the Milky Way survive and continue to form stars for billions of years? The answer lies in the balance of forces. Not every galaxy has a quasar, and not every supermassive black hole is active. Some, like the black hole at the center of our galaxy, are relatively quiet. Sagittarius A*, the supermassive black hole in the Milky Way, isn't actively feeding, which is why our galaxy still forms new stars. But in galaxies where quasars do become active, the impact can be enormous. Scientists believe that many of the massive, elliptical galaxies we see today, those that no longer form new stars, were once home to active quasars. These galaxies are now dead, with little to no star formation, likely because their central quasars expelled the gas and dust needed to sustain stellar growth. This brings us back to J1007 plus 2115. The galaxy around this quasar is in the process of being quenched. With its star-forming material being blown away by the quasar's powerful winds, it may already be on the path to becoming a dead galaxy, one where no new stars will form, leaving only the remnants of its earlier, more active life. This kind of galactic transformation may have been common in the early universe, as quasars like J1007 plus 2115 played a pivotal role in shaping the fate of their host galaxies. But the story doesn't end there. Quasars, while destructive in some ways, might also help explain how galaxies evolve over time into the stable, structured forms we see today. By clearing out excess gas and dust, these powerful winds may have helped to regulate the growth of galaxies, preventing them from becoming too massive too quickly. In a sense, quasars might act as a form of cosmic control, ensuring that galaxies evolve at a balanced pace rather than collapsing under their own weight. The discovery of J1007 plus 2115 offers a rare glimpse into this process as it unfolded in the early universe. It shows us how a supermassive black hole, with its ferocious winds, can both nurture and destroy its galaxy, shaping its evolution in profound ways. As we uncover more quasars from this distant era, we'll be able to paint a clearer picture of how galaxies like the Milky Way came to be, and how the most extreme forces in the universe contributed to their creation. Ultimately, quasars represent a kind of cosmic paradox. They are engines of immense destruction, capable of wiping out star formation and killing galaxies. Yet, at the same time, they play a crucial role in the grand scheme of galactic evolution. They are both creators and destroyers, helping to shape the universe we see today and driving the transformation of galaxies over billions of years. This dual role, both nurturing and quenching, makes quasars one of the most fascinating phenomena in astronomy. And the more we learn about them, the more we realize just how vital they are to understanding the very fabric of our universe. The discovery of quasar J1007 plus 2115 opens a new chapter in our understanding of the early universe. With tools like the James Webb Space Telescope, we're just scratching the surface of what we can learn about these ancient cosmic giants. Researchers are eager to find more quasars from the first billion years after the Big Bang to better understand how they shaped the galaxies around them and influenced the overall structure of the universe. Every new quasar we discover brings us closer to unlocking the mysteries of galaxy formation and evolution. We now realize that these powerful winds weren't just destroying galaxies, they were shaping them, regulating their growth, and helping to mold the universe into what we see today. As we continue to uncover the secrets of the cosmos, each discovery changes our understanding of where we come from. What other mysteries might be out there, waiting to be uncovered? Stay curious, keep questioning, and never stop exploring the universe. It has far more to teach us than we ever imagined.